discussing about a new compound, we have to discuss about the properties, structure, right? Now we are going to discuss about the preparation methods for amines. Preparation methods. Okay. See, first preparation method, that is reduction of nitro compounds. Reduction of nitro compounds. What do you mean by reduction? We know what is reduction. Reduction means we know that is the addition of hydrogen. One definition we know it is the reduction. Reduction means it is the addition of hydrogen. Or we can say it is the removal of oxygen. It is the addition of hydrogen or removal of oxygen. Okay. Then, see, nitro compound. See, we are going to prepare amines from nitro compound. Before that, what is nitro group? And NH2 is amino group. Then what is nitro group? NO2 group is called a nitro group. NO2 group is called a nitro group. Okay. Nitro compounds are reduced to amines when passed through hydrogen gas. See, nitro compounds are reduced. If you are reducing, we need a reducing agent. Okay, so nitro compounds are reduced to amines when passed through hydrogen gas in presence of finely divided nickel, platinum, or palladium, and also by reduction with the metals in acidic medium. Memorize. How can we produce amino compound? How can we produce amines from nitro compound? Whatever it may be, alkyl or aryl, whatever it may be, leave it. Anyway, the nitro compounds can be converted into amines by reaction, by using reduction reaction. So what is the reducing agent using here? That is very, very important. The reducing agent we are using here is, we can use platinum, palladium and nickel. Any metal we can use. Okay, then nitro compounds are reduced to amines when passed through hydrogen gas in presence of finely divided nickel platinum. Means they are the catalyst, right? Because these transition metals are normally acting as the catalyst. So they can be also produced by reduction with the metals in acidic media also. Okay, I will explain with an example. See, this is a nitro compound. This is called a nitrobenzene. This is called a nitrobenzene. Nitrobenzene on reaction with, I told you, reduction, right? Means suppose you can use platinum, you can use palladium, you can use nickel, you can use. Here I am using palladium. In alcoholic medium, important. Means we have to use ethanolic medium. Then what is the product you are getting? Aniline. Aniline. Okay? Yes. Next, reduction with iron scraps and hydrochloric acid in presence of, means is preferred because of the ferrous chloride. Ferrous chloride is FeCl2, iron chloride, iron 2 chloride. Okay. Form gets hydrolyzed to release hydrochloric acid during the reaction. What is FeCl2? FeCl2 is iron 2 chloride, or we can call it as ferrous chloride. Then what is ferric chloride? You know that is FeCl3. Okay. Then, thus to initiate the reaction, only a small amount of hydrochloric acid is required. One more thing, as I told you. Okay, means the amount of hydrochloric acid, the initiate the reaction, we can start the reaction using a small amount of hydrochloric acid. See, in the first one, we are using the nitro compound, and what is the reagent using here? We can pass the hydrogen gas through this compound in presence of the metals like nickel, platinum, palladium, I told you. Okay, or we can use the acidic medium, the metals in acidic medium also. Second one is, we are treating with iron scraps and hydrochloric acid in presence of ferrous chloride formed gets hydrolyzed to release hydrochloric acid during the reaction. This one. Okay, so this is the second reaction. To initiate the reaction, only a small amount of hydrochloric acid is required. Got it? So this is the method of preparation from nitro compound. Nitro compound. Okay, then next one, ammonolysis of alkyl halide. What is ammonolysis? What is the meaning of lysis? Lysis means breaking. Breaking. What is ammonolysis? Ammonolysis. Ammonolysis or ammonolysis means we are breaking a compound. Breaking a compound using ammonia. You know hydrolysis, right? Hydrolysis means we are breaking a compound with water. Ammonolysis means we are breaking a compound with ammonia. Okay, we are breaking a compound with ammonia is ammonolysis. Water is hydrolysis. So, by the ammonolysis of alkyl halide, what is alkyl halide? Alkyl halide means Ri. Any alkyl, suppose CH3I, CH3CH2I or CH3CH2Cl, RCl, RBr, RF. These are alkyl halides, right? Commonly, we are not using alkyl fluoride, alkyl iodide, alkyl chloride and alkyl bromides are common. Okay. So, a nucleophile can easily cleave the carbon-halogen bond in alkyl or benzyl halides. Nucleophile can easily cleave carbon-halogen bond in alkyl or benzyl halides. What is a nucleophile? What's a nucleophile? As I told you, nucleophile means they like the nucleus, right? Means they have a negative charge. Nucleophile have a negative charge. A nucleophile can easily cleave the carbon halogen bond in alkyl or benzyl halide. Suppose I am taking CH3 chlorine. So when a nucleophile is, you remember the nucleophilic substitution reaction, right? Yes, the same thing. Suppose a nucleophile like OH- is coming here. This can easily cleave this bond between alkyl group and halogen. Alkyl group is actually the carbon. Got it? CH3 is the alkyl group, right? But which bond we are breaking? The bond between carbon and the halogen. So the nucleophile is attacking, means breaking this bond between carbon and halogen. Then they will convert it to some desired product. Okay. As a result, in an alkyl or benzyl halide reaction with an ethanolic ammonia solution, the halogen atom is changed to an amino group through a nucleophilic substitution process. That is a nucleophilic substitution reaction. As a result, in an alkyl or benzyl halide reaction with an ethanolic ammonia solution, the halogen atom is changed to an amino group through nucleophilic substitution process. Okay. The process of cleavage of the carbon halogen bond by the ammonia molecule is shown as ammonolysis. I told you, lysis means breaking. Ammonolysis means we are breaking using ammonia. And the ammonolysis reaction is carried out in a sealed tube at 373 Kelvin temperature. This process of ammonolysis we are conducting in a sealed tube under what is the temperature? 373 Kelvin temperature. Okay, then the resulting primary amines has nucleophilic behavior and can react with an alkyl halide to form secondary and tertiary amines and finally quaternary ammonium salt. The resulting primary amines has nucleophilic behavior. Why? Because this is the nucleophilic substitution and can react with an alkyl halide to form secondary and tertiary amine. And finally, quaternary ammonium salt. What is quaternary ammonium salt? What is that? Normally in ammonia, one lone pair is there. When the hydrogen atoms are replaced by some alkyl group, it will be like this. Quaternary ammonium salt means they will make one more bond using this lone pair of electron. Got it? Suppose this one is giving to one hydrogen and forming NH4 plus, right? Then this whole compound will get a positive charge. Then what will happen? This one will NCH3 thrice hydrogen. They have a positive charge. They will combine with the chlorine. This is called a quaternary ammonium salt. Got it? Yes. By treating with the ammonium salt with a strong base, the free amines can be extracted. See, in the previous one, the ammonia is there. The lone pair is attacking the alkyl group, and the electron pairs are moving on to the halogen atom. So what will happen? This R group will come here, and the remaining halogen will go there. This is the reaction. Then the thing, see, this is the reaction. I will write once again. I will write here. Okay. See, NH3 RX. Then there is a lone pair of electron. Using the lone pair, they will attack there. Then the electrons will move there. Then you will get R group is attacking the nitrogen using, I told you, using the lone pair of electron. And you will get NH4 plus type. Means nitrogen connected to 4 bonds and they have a positive charge. Not only NH4 plus group. Means hydrogen may be replaced by alkyl groups also, right? Yes. So what is the product? R NH3 only. Plus. Then when these electrons are moving here, this halogen will get a negative charge, right? Yes. So this bond is splitting and this one will convert into X minus. That X minus, due to the attraction, they will attack here and form RNH3 plus X minus. This is, I told you, this is the ammonium salt, quaternary ammonium salt. What is quaternary? Quaternary means the 4. Means here the nitrogen normally contains 3 bonds. Here it is 4. Okay. Yes. Now, by treating this ammonium salt with a strong base, the free amines can be extracted. So this is the ammonium salt, we got it, right? Understood. Then what will happen? This ammonium salt are NH3 reaction with the base. Okay. Then what is the product you are getting? What will be the product? See, NaOH, right? So this NaOH will break and they will produce Na plus and OH minus ions. That Na plus ions will react with the Cl minus ion and produces NaCl. So this one and this one removed. Okay. Then here one OH group is there. Then what is remaining? Here RNH3Cl minus. So here the chlorine is removed with the sodium. Then here in case of RNH3 plus, one atom is excess. Normally nitrogen have only 3 bonds. Nitrogen have only 3 bonds. But here nitrogen have 4 bonds. So one more hydrogen atom will removed and it will combine with the remaining OH to produce H2O. Then what is the important product? R NH2. NH3 is not there because one hydrogen is removed with the OH group. And plus charge, no need to write. Why? Because that group is hydrogen is already removed. So no need to write the plus charge again. Got it? Yes. So that is the reaction. Ammonolysis has the disadvantage of yielding a mixture of primary, secondary and tertiary amines as well as quaternary ammonium salt. Then what is the drawback of this process? Ammoniolysis we can do in case of normal compounds, so we will get amines, right? Then what is the drawback of this method? The drawback is, in case of this ammonolysis, we will get three different products. Sometimes, not all the time, we will get, sometimes we will get three different products. We will get primary, secondary, tertiary. Then one more product is possible. See, sometimes the product will be, final product will be this one. They won't undergo the reaction again. This one will be the final product. Then what is the product then? Primary, secondary, tertiary, quaternary. That is the means if you are getting the mixture of the products, you want only primary, but you got mixture of products. Then what is the problem? You have to separate it. You have to check the boiling point, melting point, or some other methods you have to find out to separate these amines you are getting as a product. Got it? Understood? In case of this one, normally we are getting a mixture of primary, secondary, tertiary and quaternary compounds. So what we have to do? We have to separate it. So separation process means it may be depends. Sometimes it is not easy. The mixtures are not easy to separate. Primary, secondary, tertiary not easy to separate. We have to do several tests to identify which one is there, and we have to do the separation. Sometimes it becomes easy to separate it. Okay. Now, by taking large amount of ammonia, primary amines is obtained as a major product. Important. If you are taking large amount of ammonia, the product you are getting will be, the major product will be primary amine. If you are taking the more amount of ammonia for this reaction, the major other products will also form, but the major product will be primary amines. Okay. Then the order of reactivity of halides with the amines. Then I told you the halogens will undergo what type of reaction? Nucleophilic reactions, right? Means suppose alkyl halides are there, then they will also react with the amines, right? So which halide will react? Which alkyl halide? See here, ammonia is reacting with alkyl halide. Okay, this ammonia is attracting the R group, means alkyl group using the lone pair of electron. That's why this reaction is happening. So which halide ions are more reactive with ammonia? Which halide is more reactive? Definitely it will be alkyl, means iodide. Why it is alkyl iodide? See, we know in case of halogens, down the group, the size is increasing. Right? In case of halogen, down the group, the size is increasing. When the size is comparatively too high, they are not able to make strong bond, right? Yes. So in case of alkyl iodide, alkyl bromide and alkyl chloride, what is the conclusion you can give? See, alkyl iodide means iodine is there, but iodine is the biggest halogen atom for comparing to chlorine, bromine and everything. So this bond between the carbon atom of the alkyl group and iodine will be weak. Understood? When the size of the halogen is increasing, the bond become less strong. The bond become weak. When the bond become weak, it become easy to cleave. That's why this ammonia can attack. If the halogen is iodine, it will be easier to break this bond. It will be easier to attack this alkyl group. It will be easier to remove this halogen as X minus ion. Got it? Understood? So when the size of the halogen atom is increasing, it becomes easy to break the bond. So the reactivity of the halide ions will increase as iodine, bromine, chlorine, like that. So alkyl iodides are more reactive than alkyl bromide. Which is more reactive than alkyl chloride? Got it? Understood why the alkyl iodides are more reactive? Because of the bigger size of the iodine, the bond between the carbon and the iodine is weak. So it is easy to break the bond. So it is easy for the ammonia molecule to attack. It is easy to form the compound. So the reactivity will be this order. So this reactivity order you have to memorize. No need to memorize. It is simple common sense, right? Because iodine is bigger in size, because down the group halogen size is increasing. So iodine can form only weak bonds with the carbon or the halogen. So it is easy to break the bond. If the bond is easy to break, the reaction will be faster. Like that you can memorize. This concept only, the theory only. Okay. Yes, that is the first method for the preparation. Sorry, second method. First method was from nitro group, right? Nitro compound. Yes. Then third method is reduction of nitriles. What is nitrile? Tell me what is nitrile. I already told you what is nitrile, right? What is a nitrile compound? Nitrile compounds means they have CN group. Okay, CN group means the cyano group is called a nitro group or nitriles. No, not nitro, nitriles. The compounds containing CN groups are called a nitriles. Suppose here in this group, carbon is triply bonded to nitrogen. So here one bond I am replacing with some alkyl group. So these are called a alkyl nitrile. Any alkyl group, CH3, CH3, CH2, any group. Okay. Yes. This type of reaction is here. Nitrile some reduction in presence of lithium aluminum hydride or catalytic hydrogenation produces primary amines. Understood? Nitriles means these type of compounds in presence of lithium. See, this is reduction. So reduction means we need a reducing agent, that is lithium aluminum hydride. I told you, whenever they are asking about reducing agent, the first one that should come in your mind, should be lithium aluminum hydride. The second one is what? You remember? Sodium boron hydride, I told you. Got it? Yes. So the compounds containing CN groups are called alkyl nitrile. They are commonly called nitriles. Okay. So the nitrile sound reduction in presence of lithium aluminum hydride or catalytic hydrogenation produces primary amines. What is catalytic hydrogenation? What is hydrogenation? Hydrogenation means we are adding hydrogen. Addition of hydrogen is called a hydrogenation. Catalytic hydrogenation means the hydrogenation we are doing in presence of a catalyst. Hydrogenation means we are adding hydrogen. If this reaction we are doing in presence of a catalyst, that is called a catalytic hydrogenation. Okay. So nitriles on catalytic hydrogenation in presence of these type of reducing agent like lithium aluminum hydride, they will produce corresponding amines. Okay, this type of reaction is used for, see, preparation of amines containing one carbon atom more than the starting amines. Important. Very, very important. See, this is the compound. We are doing hydrogenation, right? Addition of hydrogen. So what you have to do? The best method is break here, add one molecule of hydrogen here, other molecule of hydrogen here. Then it will be RCH2NH2. So this is the compound. Got it? So if you are doing reduction of nitriles, you will get corresponding amines. And the thing is, mechanism is not there. So it is easy to memorize the equation. Got it? Mechanism is not there. So it is easy, right? Yes. But in some reactions, mechanism is there. That one you have to study well. In your board exam, if there is no mechanism in your textbook, they won't ask in your exam. Don't worry. Got it? Yes. Then reduction of amines. Don't be confused about whether if this mechanism will last. No, if the mechanism is there in your textbook, NCERT textbook, it will be there. In your, sometimes they may ask in question paper, board exam. If there is no mechanism, they won't tell you to create the mechanism. They won't tell you to write the mechanism from your imagination. No, they won't ask like that. Okay. So whatever the reaction, which one have the mechanism, study that well. Otherwise, study them, correct the reaction, means the what is the reagent, what is the product, what is the suppose catalyst, or what is the condition, reaction condition. I told you in some reaction we have to use some temperature condition, right? In some of them we have to use medium, either medium, dry either medium, alcoholic medium, aqueous medium. So that one you have to remember well. Otherwise, you won't get marks. They will cut each mark for each of the reagent, each of the medium. That is the organic chemistry. That will be the organic chemistry, means paper structure. Okay. So don't be confused about the mechanisms for these type of reaction. They won't ask. If they are in your textbook, then they will ask it. Got it? Yes. Okay. Then see next one. So reduction of nitrile is clear, right? So by doing the reduction in case of nitriles, we will produce amines. Next one, reduction of amides. Important. What I mean by amide? RNH2 is amines, right? RCONH2 are called amides. RCONH2 is called amides. Okay, you know the urea, you know, right? It's a fertilizer, chemical fertilizer. So it is a diamide. It's a type of amide actually, diamide. Okay, yes. So what is, how can we prepare the amides from these type of amides? Amides on reduction with the lithium aluminum hydride. See, in many reactions, the reagents are same, I told you. Okay, so the amides on reaction with the lithium, reduction with the lithium aluminum hydride gives amines as the product. Got it? Yes. So this one also you have to remember. So I told you the reaction conditions, the reaction medium, all of them are important. Got it? Any doubt? Any doubt? Sure? Yes. Now, next one. So this preparation is clear. Next one is we are going to study about a name reaction. So in aldehydes, ketones, alcohols, then which one, what is the other topics we studied? Means many of the organic chapters we discussed about the name reactions. You remember Itard's reaction, then which one is the other one? Williamson synthesis, different reactions, right? See, again some name reactions are coming. So again I am telling you, name reactions, study well. What is the reagent, what is the product, like that you have to study. Sometimes in question paper they may ask like explain Gabriel thalamide synthesis, like that. They will specifically tell the name and they will tell you to write the reaction. They will tell you to write the sometimes the mechanisms. If it is there, they may ask the mechanism. Okay, so next name reaction is Gabriel thalamide synthesis. Gabriel thalamide synthesis. Important. Very important. Very. See, in the past papers you can see they are asking used to ask these questions in essay also. Okay, so very important. Gabriel thalamide synthesis. This synthesis is mainly used for the preparation of primary amines. Important. Again, used for the preparation of primary amines. When ethanolic potassium hydroxide is added to thalamide, a potassium salt is formed. See the reagents I told you. Remember the reagents. Note it. Okay. This potassium salt is then heated with an alkyl halide and then undergoes alkaline hydrolysis to yield the corresponding primary amine. See, this is thalamide. What is thalamide? This compound is called a thalamide. Okay, you know phthalic acid, right? What is phthalic acid? Phthalic acid. What is benzoic acid? Yeah, I have to start from the benzoic acid. Then only you will know, you know what is phthalic acid, right? Yes. So what is benzoic acid? This is benzoic acid. We know. What is salicylic acid? From the benzoic acid, in the next position we are adding some OH group. That is called salicylic acid. Next one is phthalic acid. Phthalic acid means it is a dicarboxylic acid. See, two COOH groups are there. Phthalic acid. Phthalic acid. Okay. Then this phthalic acid is normally it is a dicarboxylic acid, I told you. So using the phthalic acid we can produce phthalimide. What is phthalimide? This is phthalimide. So I told you amide means it is CONH2 group, right? So phthalimide means amide means CONH2. So phthalimide means, see, phthalic means you have to remember this one. Two groups, COH group is there, that is phthalic acid, we have to know. Then phthalimates means, see, this is phthalimide. This is the first time you are hearing about phthalimide, right? Yes. This is phthalimide. So when the phthalimide is on reaction with the potassium hydroxide, what will happen? See, when ethanolic potassium hydroxide is added to phthalimide, a potassium salt is formed. How? See, this hydrogen and this KOH, right? So when this one is reacting with the KOH, hydrogen from here, OH from here will be removed as water minus H2O. Then this nitrogen will combine with the remaining one and they will form CO. Got it? Yes. This is the potassium salt of phthalimide. Okay, NK+. Now, what you have to do? A potassium salt is formed. The potassium salt is then heated with the alkyl halide. Whatever the, suppose I told you the highest reaction rate will be for alkyl iodide, right? Yes, you can take that one, no problem. So this potassium salt is reacting with the alkyl halide, like RX type, means CH3I, any other one. Okay. Then whatever the alkyl group you are taking here, it will be substituted in this position. Suppose we are taking CH3. So what will be the product? Instead of this K plus, it becomes CH3. That is called an alkyl phthalimide. Okay. Aromatic primary amines can be, see, this one is clear, right? This potassium salt is heated with alkyl halide and then undergoes alkaline hydrolysis to yield the corresponding primary amine. Then what you have to do? Do hydrolysis. Then on the hydrolysis, you will get the corresponding product, primary amine you will get. Okay, understood, right? Yes. Now, aromatic primary amines cannot be prepared by this method as aryl halides do not undergo electrophilic substitution with the anion formed by phthalimide. So, aromatic primary amines we cannot prepare by this method. Only aliphatic, means the normal one. Got it? That is called a Gabriel phthalimide synthesis. So this is used for the preparation of primary amines. Got it? Yes. So this is Gabriel phthalimide synthesis. Next one is Hofmann-bromamide degradation reaction. Hofmann-bromamide degradation reaction. Till here is clear, right? Just go through the previous topic again. Then I will teach you the last one. Okay. See, just go through this one. What are the preparation methods I told you? First one is reduction of nitro compound. Nitro compounds normally nitro group is there. The nitro compound on reaction with the high means reduction means we have to react with hydrogen in presence of a catalyst like you can use nickel, platinum or palladium. Then they will produce corresponding amines. Reaction with the iron scraps and hydrochloric acid is preferred because the ferrous chloride formed gets hydrolyzed to release hydrochloric acid during the reaction, as I told you. So initiate the reaction, only a small amount of hydrochloric acid is required. The same thing I told you. Okay, so clear, right? Yes. Then next method of preparation we discussed is ammonolysis of alkyl halide. What is ammonolysis of alkyl halide? Ammonolysis. Ammonolysis means we are breaking a compound with ammonia. Ammonolysis. A nucleophile can easily cleave the carbon halogen bond in alkyl or benzyl halide. So I told you. So we have to break the compound with ammonia. Okay. So see, the products you are getting, I explained the mechanism also. I explained, right? Yes. See what is happening. The nitrogen will attack the lone base, will attack the alkyl group. Then this compound will be formed. This one non reaction with the base, they will produce the corresponding compound. Then see, the important thing is I told you the rate of the reaction. Which halogen will, alkyl halide will react more? As I told you, alkyl iodide will react more because the reason is the bond between carbon and iodine will be very weak because of the high size of the iodine. So it is easy to break. So they will be it is easy to form the compound using this alkyl iodide. Okay, so the rate of reaction will be higher in alkyl iodides. Next one, reduction of nitriles. I told you nitriles. What is nitrile? Nitrile means the CN group containing compounds. The CN group is called the nitrile group, and the compounds containing the hydrocarbon containing CN group is called the alkyl nitriles. I told you. Then this one is same reaction. Reduction, they will produce corresponding amines. Then I discussed about the reduction of amides, right? What is the reduction of amides? Reduction of amides means RCONH2 is called amides. So the amides on reduction using same thing. Lithium aluminum hydride, they will produce the corresponding compound. Okay. Then we discussed about the Gabriel thalamide synthesis. So I told you what is thalamide. Before moving to the thalamide, I told you what is the thalic acid. From the thalic acid, actually the thalamide is forming. Okay, thalic anhydride is there. Different related compounds are there. Okay, so it is mainly used for preparation of primary amines. I told you, which is important. Okay, then the same thing. This is the amide. This is the thalamide we are taking. Then we are treating with potassium hydroxide. You will get a salt that will on reaction with suppose the alkyl halide. They will produce the corresponding thalamide. Okay, then the thalamide on the hydrolysis, alkyl hydrolysis to produce the corresponding primary amine. Okay, it's clear. Okay, then the next name reaction, the next method for the preparation is Hofmann bromamide degradation reaction. Hofmann bromamide degradation reaction. Again, important. See, as I told you, all the name reactions are important. Okay, see, Hofmann developed a process for preparation of primary amines. See, Gabriel thalamide synthesis is also for primary amines. Hofmann bromide degradation is also for primary amines by treating an amide with a bromine in aqueous or ethanolic solution of sodium hydroxide. See, these the reagents are important. Primary amines by treating an amide. See, in Gabriel thalamide also I told you we are using with a thalamide, right? See, in both we are using same amides. But that is thalamide, that is called Gabriel thalamide synthesis. This is another common amide. Amide means they should have CONH2 group. So this is the compound on reaction with the bromine. Then sodium hydroxide is there, right? Yes. So this is the compound we are getting. Amines and the side products also. Okay, if you don't remember the side products also, leave it. You have to write the correct product that we are going to get from this particular reaction. Okay, then in this degradation, the migration of an aryl or alkyl group takes place from the carbonyl carbon of the amide to the nitrogen atom. Important. See, I will explain. This is the compound RCONH2. In presence of bromine is there, in presence of sodium hydroxide is also there. So in this reaction, as I told you, what will happen? See, this is the migration of alkyl or aryl group from the carbonyl carbon. This is the carbonyl carbon. It is the migration of alkyl or aryl group from the carbonyl carbon to the nitrogen atom. Okay. See, then what will happen? This is the compound, right? So this R group will migrate to nitrogen. Now this R group is connected to this carbonyl CO group. Then during the reaction, this R group will migrate to nitrogen. So what is the product? R NH2. Then see, this is the product. This is the required product, right? Product, you got it because this is due to the migration of this alkyl group towards the nitrogen. Then what about the remaining products? See, this is RCONH2. Then the remaining product, the remaining oxygen and these, they will combine together to produce Na2CO3, sodium carbonate. The sodium remaining here react with the bromine to produce sodium bromide. Then the remaining will combine together to produce what? Got it. So this is the reaction. So this is the migration of the alkyl group. CS3 means any group, alkyl group, R group towards the nitrogen atom. That's how you are getting the product. Okay. The resultant amine so formed contain one carbon less than that of the present in amine. Why? See, one example. Okay. See, I'm taking this compound. CH3 CO NH2. This is the compound, right? Yes. So in this compound, how many carbon atoms are there? 1, 2. After the reaction, the product you are getting is, see, the CH3 group will migrate to this nitrogen and the product you are getting is CH3 NH2. This is the product you are getting from the reaction, right? Then see the number of carbon atom. This is the reactant you used. This is the product formed. In the reactant, you can see 1 carbon, 2 carbon, and this is NH2. So in the product, you see NH2 is still there, but in the reactant, 2 carbon, but in the product, only 1 carbon. That's why they are telling amine so formed contains 1 carbon less than that present in the amine. Got it? Because the CO group is removing actually. The carbonyl group is removing. That's why. Okay. The carbonyl group is removing from that amine and this alkyl group is migrating. That's why the product have 1 carbon less. Okay. So this is Hofmann-bromide reaction. So both the reactions, Gabriel-Thalamide synthesis, Hofmann reaction, both of them we are using for the preparation of primary amines mainly. Okay.